Hi, I'm Nenad, one of the Haxe developers that worked on the conversion of Flash browser client to Haxe. 2 years ago, we had a presentation in Amsterdam where we presented the work in progress version of the conversion workflow. But today, I can say yes, we made it. So we actually moved front-end also Flash browser client to Haxe, and it's fully run by Haxe now. So that's why this presentation is basically looking back and showing up what the decisions that we made, what was good, what could have been done better, and probably there will be some takeaways from this presentation. So the presentation has 3 parts. One is just some words about us. Second part is what went well and what could have been avoided actually. So who we are InnoGames. So InnoGames is a game developer, one of the largest game developer in Germany, based in Hamburg with more than 400 employees, and we are doing nowadays mostly mobile games, but we have some browser games that were done in the past, which most of them have also mobile clients, and this year we break the mark of 1 billion revenue, lifetime revenue in InnoGames. One of these browser games happens to be a Forge of Empires, which is a very successful one, which is one of the largest browser games on the market. It's really difficult to measure the browser market because there are not valid sources or reliable sources of information, but according to our data, we think it's one of the largest, if not largest, browser game on the market. It's a city building game. It's a city building game with some strategy component to it. So the players have city, they have limited building area where they can build their buildings. Can have multiple city actually now. Have strategic battle that they can fight either in player versus environment mode, or in player versus player mode, or even guild versus guild mode. It has this historical timeline in our, so the players kind of research the different historical ages, so they can experience the architecture from the ages in the city as well. We also break this mark with Forge, like 500 million lifetime revenue. It's released 2012, so it's kind of old game, like 8 years old, with 8 years old source base. And as I said, it's a browser. We have browser client, but as well we are on most of the popular mobile platforms, and we support also most of the browsers. So as you see, the Forge make us quite a lot of money, so we just cannot let it die with Flash together, and we had to do something and make sure that our players can still enjoy our browser client, not only enjoy it, but also provide the same experience as, or if not better, at least the same experience as Flash client. So one of the important stuff that we did is prototyping, namely in order to reduce the risks and to get more glimpse into technologies and capabilities of technologies, we explored actually many technologies, which at the end we tried to create prototypes of these 3. For Create.js, we didn't manage to create a workable prototype because it has really poor actions Flash API there, and the JavaScript converters were not working super well, like ActionScript to JavaScript converter. But in Egret and TypeScript and OpenFL, we managed to create a workable prototype, and the prototype actually should prove that our Starlink or GPU rendering was working properly, the UI elements were working properly, backend communication is working properly. So these are kind of requirements that we had to prove that is working with a certain technology in order to consider it in the choice if we want to go with one technology or the other. And obviously both of these technologies had that, but the problem with Egret is because it's a proprietary technology. Basically it was a set of tools, it's a toolkit, and they have also converters, all this stuff. But the thing is that the converter was already producing good quality TypeScript code, but it was not like the things that it could not understand. It would just put a reflection, and these things have to be fixed. But because this is a proprietary tool, we have no access to the code, and we couldn't do anything there. But with OpenFL in Haxe, it's completely different story, as the open source, and even the time that we took to create the prototype was much less than with Egret. So this is the prototype, actually done fairly quickly, like back mid 2016. So this is city on a Starlink layer. Basically, most of the buildings with animations are there working. This weird red ball that is, or circle that is flying around, is actually proving that the twins are working properly. Also, I mean, the video is quite long, but we have UI here working. We have later Windows and backend communication working. So this is actually the prototype that we did in OpenFL. We also did the same one with Egret, but we at the end decided to use Haxe and OpenFL because of the reasons I already mentioned. The second good part about this project was the project management itself. It was fairly well managed project, I can say. We had clear goals from very beginning, so no feature freeze, meaning that we don't get certain state of ActionScript code base and then convert that and start, or taking that code base and try to convert it while the other one is still developing and having new features. Then that would end up in feature catch up, which is, we have experience here that is not going super well. Then no game rewrite, so we didn't want to rewrite the game. Prefer automation, so most like the processes there should be as automated as much as possible, and the comparable performance, comparable to Flash client. This is interesting one. Kudos to QA. Actually, we had a benchmark defined by the Flash client, and every release, so we were releasing on 2 weeks, we were doing the tests across all the browsers. We were testing HTML5 performance, and we were comparing the results and seeing where we have problems and how to fix them. And the interesting thing here is that we, while we were doing this conversion, we were also optimizing ActionScript. So we are actually always comparing to the best ActionScript version ever. So it was really interesting catch up. So we had to do some decisions which helped us to reach that point. And yeah, all the tests were performed on the famous Beast machine. So it was really low-end machine, Windows machine. We had a good plan, so we have a really clearly defined roadmap with clearly defined milestones. Like milestone 0 is error-free compilation. Milestone 1 is, for instance, I don't know, city working and so on. So it was really well defined, and we were having clear focus on what we want to achieve. And as I said, we tried to keep the risk really low, so we didn't make decisions lightly. So we tried to have reasons why we take certain decisions, and we had also very good and smooth release, basically, in the release plan, because we haven't been on pressure to release like now. And this is the release plan, which was actually done in 2018. As you see, 2018 was also not super bad year for Flash, so we have space to not rush the release. So in February we released beta as optional. So in the settings in the game, there was a property where the setting where the players can opt in and choose to play in HTML5 client. 2 months later, we released. Of course, there were players that opt in, and we had some feedback. We were fixing we were reacting upon the feedback, and then in April we released beta by default. 2 months later, we released live optional, the same as beta. So it was a setting where the players can opt in. Then in July we ran A/B tests where like 50% of new registrations were running on HTML5, 50% were running on Flash, and we had also good results in A/B tests, which ended up by having live by default in November 2018, and it's like live default on live since that. We have around 85 or 86% participation on HTML5 client. Yeah, moving on, also very important thing was that we choose to use open source. Some of the reasons I already mentioned. There is no vendor locked in. As I said, with the exit, it was really difficult to adjust the conversion output. And here was also interesting situations that we have here when we started actually with the conversion process. When we were exploring situations, we heard that some company in Hamburg here, actually the gaming company, they have already converted their product from ActionScript to Haxe. And then we said, okay, maybe we can buy that converter instead of like going through the whole thing. And then when we talked to them, we tried to negotiate, but they actually wanted to just sell us the conversion, not the converter. So they wanted to get the code, convert it, and get back the hex. Even that was a viable option for us, but at the end it ended up that the converter was not actually working, and the code that it was producing was really, don't want to look into it, and you can't actually work on top, like, because we wanted after the conversion to move to Haxe development. So yeah, available source code, this is clear. Lower costs, basically no cost for using the open source, and community, at least before we started digging into the source and doing the changes ourselves, was super responsive. Actually, we were filing issues that like in next days were fixed, so that was really, really good. So really good that we made the choice to go with open source technology. Moving on, coming to the technical part, this was like really good tool that we developed back then. It's mocked compilation. I'm going to explain what does it mean. It means this peacock here, meaning that we were basically compiling the classes one by one in installation. What does it mean compiling in installation is that this mocked, so like we were passing the source code through the tool, pre-parser, it will create the mocked source code, which means that the code is stripped from any implementation. It was just public properties and functions. And this code, this code when converted to Haxe, so it's also Haxe code without implementation, was compiling without any errors. And then we do the same thing with the normal code. And then here we have the converted Haxe code. And then what we were doing, we take one class from the converted code, replace that class in the mocked code, and compile. So these environments are actually one class compilation at a time. So we're compiling each class individually. Besides that, this tool was also very good with reporting. So there were really rich reports with amount of errors, importance of errors, which class had most of errors, and so on. So we could prioritize and work good, and plan their fixing. And it was really invaluable for us to come to the point that we are like zero compilation errors. Which also is bringing us to annotation. This is another tool which we used in ActionScript code in order to instruct our conversion tools to take some decisions. Namely, in Flash, we have some dynamic types like dictionary and array or functions where you can't specify the key or the types of the elements, and therefore we needed this system or this annotation feature, which we were adding comments like this hex type, which makes changes the type of the field, or suppress, which just ignores the code when converting, or inject, which was adding string into the classes. So it's more comments in ActionScript code, so the ActionScript code was not harmed at all, and we had few of them that we were using. At the end, in the latest actually state of the ActionScript source code, we have only hex type, so the other ones were just dropped. Okay, that was the part which brought us to the zero compilation errors. Now when we compile without errors, we need to run the game, and to run the game we need assets. And for ActionScript client we use SVFs, and SVFs are not really handy to use in like asset bundles that were not possible to use in HTML5. And also we were using compressed textures for the city, which were also not supported in OpenFL. So what we did, the question was, should we just have another asset pipeline for HTML5, or just make something that we use the same assets, which actually was really good decision that we made to to use the same assets, we needed to change all the entire ActionScript code basically to use the texture atlases instead of SVFs as asset bundles. And the other thing, we needed to contribute to OpenFL to be able to use the compressed textures into HTML5 client. Yeah, this one was also, we made the wrong decision, which led us to actually make the right decision afterwards. I'm going to talk about that one later. Continuous conversion, this was really nice that we had, because what this means is that every time, like every commit is converted to Haxe in an automated way. It was running on Jenkins, so every pull request was compiling both Flash and ActionScript and HTML5 clients, and based on that was like failed or success the pull request actually. And also we were running UI tests, the same UI tests on both clients. So this was really good that we did. So we could make sure that the quality of the HTML5 client is the same level as Flash pretty early in the process. Then came and started this macro magic thing around. We noticed, we are using robot legs, which uses Swiss suspenders, and they are in order to do this like impedance injection framework, and in order to make these injections, the Swiss suspenders injector need to have type information, and in order to have type information, it was using this RTTI runtime type information meta tag in Haxe, which was producing this XMLs in JavaScript code. And because we use a lot of classes with dependency injection, there are a lot of entries and XMLs in JavaScript, and the injection was also not super fast. Therefore, we then created this macro-based injector, which actually we would mark with this marker interface, type description aware, a class that has to be processed by the macro, and the macro will basically generate type description objects from the type, which is later used by the injector when it needs to inject into that type. Moving on, canvas rendering was actually something that we used not super often, but often enough to have some performance drops on the browser client, and therefore we had to reduce the usages. Primarily because this guy don't like canvases. All the performance tests from now on were basically based on Edge performance, because the other browsers more or less were working well, but Edge was complaining on little stuff. After that, was that enough for a release on Edge? No, we had to do something more. So we introduced the batching, which is basically every modern game engine has batching, but OpenFL does not support it yet, so we had to implement it ourselves. Batching is basically rendering several display objects which share the same render state in one draw call. So we had to implement it ourselves, and then furthermore, in order to be able to use this texture atlas asset bundles efficiently, we needed to implement SubBitmap data, because before implementing SubBitmap data, how the rendering was working is just creating texture of each asset individually and rendering that, which is super not efficient. And then we created SubBitmap data, which is basically a bitmap data that has parent texture, which is this texture atlas, and also data about the region it is described. So each texture atlas basically has a bunch of SubBitmap data inside, and we were able to render like UIs which use one texture atlas basically in one draw call. These two things, like batching and SubBitmap data, already reduced the draw calls a lot. Was that enough? Of course not. Edge was not happy also with that changes, so we needed to take the batching on steroids and implement MultiTextureBatching. What it is actually batching is rendering the display object that have the same texture atlas in one draw call. This is the rendering of display object which have which are like, or use different texture atlas in one draw call. How many texture atlases depends on the hardware. There is a property where you can ask the WebGL how many textures you can render in one draw call, and it will actually give you the number. What we were doing was that we were uploading this maximum amount of textures to the GPU and then just render all the display objects that use those textures in one draw call, which reduced the draw calls significantly. Like the thorough or detailed talk about how this, or explanation how this thing works, you can follow on this link. So it's a presentation of them and some of the earlier Haxe apps, actually. Was that enough? Oh, this guy is now happy. Okay, 60 FPS. Was that enough? Of course not. Because there is another bad boy in the block. So it's Internet Explorer. It's like, funny enough, it has really a big amount of revenues coming from Internet Explorer, and we couldn't just let those players down, and we had to do something. The thing was that even though the HTML5 client was running on Internet Explorer, there were like many context losses, and often it would not recover from the context loss. And the idea that we had there is that we need to use our Flash-based client for Internet Explorer. But if we use the current workflow, we couldn't move basically to Haxe, because we were compiling a Flash client from ActionScript code and HTML5 client from Haxe code. And our converter, like the old converter, was really bound to the HTML5, and OpenFL changes were also bound to the HTML5 target. So we decided to do a new converter, which, besides fixing the problem that we can move to Haxe, because it produces Haxe code that can be compiled to Flash and HTML5. It also produces better output, so we can. Although the output was not super bad for the old converter, but this one was even more better. It's using less reflection, more strict typing, and so on. And it was a simpler workflow, because it was just one tool: source code, converter, converted code, and just compile. The interesting thing here is that we don't use OpenFL for Flash. We compile against player global, so Flash library directly here. And OpenFL is only used for HTML5. Here is also detailed explanation how the converter is working. That's also some of the Haxe apps before. Yeah. Last but not least is transition to Haxe. This happened like 2 months ago, almost, or so. I wanted to mention it because even though it sounds simple, like just commit Haxe code and use it, it was not that simple. Change the file extension, exactly. Because we have running branches, like features from, and the code structure was also, like the folder structure was not so adjusted, so we had to do it like gradually adjust the folder structure first. So the main source, in the main source folder is Haxe, even though the Haxe is not main source, so it was also dropped. And then when we had all the branches that accepted the new folder structures, only then we basically converted the code. And then we had also only one end task that was basically converting the branches that were branched out before the transition to Haxe. And now we are running fully on Haxe, basically. Okay, so these were the good things. So not that the following things are bad, but what probably we would not do if we just start the whole project again was that we had, we had a rather complex workflow, even though it was not super complex, and at some point we didn't even pay attention to the workflow because we were mostly focused here in this part. We could have, because these two tools are quite similar, preparser and converter, and some of the conversion rules were in preparser, some of the conversion rules were in converter. And the reason for that was that we started with the preparser and more compilation way before we started with the converter and improving converter. So if we start again, we probably will move all the rules here or the other way around. I mean, the new converter is already basically doing that, so we have merged the tool actually in one tool. The second thing was probably the worst thing that we did, that we choose this the change management process. Namely, we created, it's difficult to explain, but I'll try my best. We wanted to have the source code Haxe source on the repository, so we created a special repository. So this is the master Haxe branch that was deployed nightly, and then we had the conversion branch, which was the master ActionScript master branch, always converted, and we were never merging here. We just have the latest Haxe ActionScript code here. And then we have the develop branch, where we would branch and to fix the runtime issues. But what happened was that sometimes when you fix something here, then there could be a ActionScript change, which is actually coming like ActionScript change on the actual code from exactly the same part, and then this resulted with the merge conflict hell. And besides that, we had to we had to do things manually. We always had to merge branches manually, so the conversion to develop and resolving this merge conflict manually, and the code bases started to go apart, ActionScript and Haxe, and therefore we stopped this quite early, I'd say, so which was really good decision, and then decided for this automated conversions, which was running like automatically on every commit. And the third thing was, well, even though it was not too bad at the beginning, then at the end ended up to write basically the whole new converter. That we were super focused on HTML5 target at the beginning, so the whole workflow was developed to compile to HTML5 target properly. But then when we needed to have Flash target, then it was not possible. We had to develop a new converter. Therefore, this is kind of a thing that we probably, if we start over, we try to be as cross-platform as possible directly. With that said, I want to restate again that Forge is now fully Hex-driven, the Forge browser, client, and yeah, thank you very much. So if there are questions, the time is now.
No question on
Okay.
Twitch. There's only claps.
Oh, thank you. Thank you, Twitch. So then, that's it.